Fine. So today we'll start with data warehouse concepts. So what is meant by data warehouse? Any idea? Anyone?
Data
It's like database only.
Yeah, please go ahead.
Data warehousing is a it's actually it's not a physical it's only where we store like different subject areas,
Yeah.
not the single one.
Yeah. We can store the data in particular house, right?
Yeah, and data warehouse is like a database, but it stores a historical data. Like databases, they doesn't store a historical data, right?
Very good. Yes. Correct. See, while using like data warehouse, we have two authors. One is Ralph Kimball, other one is Bill Inman. So one author is saying data warehouse is a relational database which is using query and analysis purpose. So data warehouse is a relational database, so which is using query and analysis purpose. So I suppose I have 50 years data in the data warehouse. I want to get like since 1972 till years data. I have entire data warehouse, but I want particular year data. Suppose I want 1999 year data I required. I want to load into that table. So how to like what is the your approaches? Nipun?
Yeah, just go to that year, pull the data out.
Very good. So how to get the like exact year data? If you want to go there, how will you go directly to there?
Using SQL.
Pardon?
Using SQL.
Very good. We have to write queries, right?
Yes.
So that's why they are mentioning data warehouse is a relational database which is using for query and analysis purpose. So whatever required data you want, we have to write queries. Based on query, we have to get results at particular area. And also it can be used analysis purpose. Analysis means I have 50 years data. So what is the data I have entire 50 years data? We have to analyze. This is what like Ralph Kimball is saying. Any questions here? Is it clear?
Like I have a question. Like analysis purpose is like after like creating a data warehouse, like a database in a data warehouse, then you use that data for analysis purpose. Is that right?
Yeah, what is the data I have? I have to check it, analyzing.
Okay, that comes under different sector. Like, is it included in data warehouse? Like, you use it in Informatica, or else does it come for some BI? I heard like it's a BI tool.
No,
You
that
use
is
BI.
different. That is different. Only you have to analyze only data warehouse. That's it.
Okay, okay.
There are like
I got it.
different tools we are using, but as of now we are using data warehouse means we have to analyze entire like 50 years data. What are the data we have? Fine. So, and one more author we have like Bill Inman. So Bill Inman, he is saying data warehouse is a subject oriented, integrated, time variant, non-volatile. See, what is meant by subject oriented? Suppose I have one table. I have like different columns: customer ID, customer name, customer location. Each column has a subject. We can call it as a subject. Or I have like multiple tables: customer table, customer department table, employee table. Each table has a subject. Or we have like different domains like banking, healthcare, financial, or like telecom. So whatever it is, like each and everyone as a subject. And one more thing we have integrated. So I have like multiple tables. I want to club all the tables like integration. I have 5 tables. I want to integrate clubbing in all the 5 tables into one table. This is called like integration. And one more thing we have, it's a non-volatile. We can't edit and delete the data, just we can analyze the data by the non-volatile. It's like nothing but a data warehouse. And one more thing, time variant. So I want to load every 1 hour or like every day or like weekly or monthly based on our requirement we can load. Fine. Subject oriented means we can choose any one subject. Integrated means we want to club different tables or like domains and all or columns and all. And non-volatile means we can't change the data. And one more thing, time variant. So based on the time loading, so 1 hourly basis or like daily basis or weekly basis or monthly basis, quarterly or half-yearly, it's based on our requirement we can do it. So you cannot see my screen. Fine. That's fine. Are you able to see my screens now? Yeah.
Yes.
That's fine. Now this is called like data warehouse. In the like data warehouse we have data mods also. What is meant by data mod? Any idea?
It is subset of data warehouse.
Very good. Yes. It's a subset of data warehouse. So why we are using like subsets? So as of now we discussed in the initial time. So I want particular year data. So what are the approaches you have? Tell me. So if you go for like bottom level or top level. So how much time it will take to reach to 1999 year data? It's taking lengthy process, right? So that we have to create different data mods. See, I have 50 years data, 10 years data into one data mod, another 10 years data into one more data mod. Like that we are splitting into 5 data mods, different data mods. So now 70 to 80 one data mod, and 80 to 90 one data mod, and 90 to 2000 like third data mod. So we can go for directly third data mod. We have to pick the data, all the data we can load into corresponding target table. We'll get the only 1999 years data. So like that we have to use data mods. Is it clear?
Yes.
Fine. Fine. So next we have OLAP, OLTP. So what is meant by OLTP? Anyone?
Online transaction processing. It takes the data of day-to-day activities.
Very good.
Online analytical processing.
Okay.
Which is used for analysis purposes.
Yeah.
Data comes into analysis.
Good. So OLAP means it's maintaining only data warehouse and data warehouse. OLTP means we are going to maintaining only current data. So OLTP, its performance wise, it's very fast always because of we are having very less data. And OLAP we have almost 50 years data. So it taking lengthy process. It's like performance wise, it's go down. And we can do any modifications by using OLTP. We can like insert or update or delete whatever you want. And by using like OLAP, we can't do anything. And OLTP is a normalized. So I have one table. I want to split into one table into multiple tables. We can split it. So based on our requirement, I want to use only like particular columns I required. So we can go for like normalized. But denormalized we are using under OLAP. So what is the use of denormalized means? So I want entire table like a report. How to generate the reports? So for splitting purpose, normalizer like OLTP is better. But I want to generate entire table report. If we can split like multiple tables, I want to generate each and every table on one report. It's taking like a lengthy process again. So I don't want to go for like that. I want entire table one report. In that case, we'll go for like OLAP. Is it fine? Or any questions you have? Fine. Then we have different approaches. We have see the document here. I didn't see another no. Are you able to see my document? We have two approaches, top down approach and bottom up approach. So what is meant by top down approach? First we have to build the entire data warehouse, then we are going to split into different data modes. It's like I have 50 years data, so I'm going to split into 10 years into one data mode. Like that it can be called top down approach. So bottom up approach means first we have to create data modes, then we are integrating, and then we are building into data warehouse. It is called bottom up approach. It's quite like vice versa, top down and bottom approach. And like top down approach means we always choose star schema, and bottom approach means we'll go for like snowflake schema. So we have data warehouse different schemas: star schema, snowflake schema, and galaxy schema. So what is meant by star schema? What is meant by snowflake schema? Star schema means it contains centralized fact table. The fact tables are surrounded by different dimensions. See the below diagram. I have one fact table. It's surrounded by different dimensions. The fact is sales. The fact is having different. Date is one dimension. Store is one dimension. Product is one dimension. This is called like, suppose it's like healthcare. If it is banking means it's like a customer is fact table, and what is the customer like investment date, and also where the what are the like different branches. Branches is one dimension. So what are the regions we are using? So this one is the one dimension. So like what are the amount they are going to invest in? Like we have like different dimensions. So one fact table we have multiple dimensions. But that too we are using one fact table, only one connection like relation, one dimension table. So one to one or one to many or many to one. There is no many to many here by using like star schema. And also performance wise, it's like a very fast compared to snowflake schema. This like star schema. This star schema and all always it's like a denormalized as well as like a dimension table and fact tables both are denormalized. And coming to snowflake schema also similar to star schema. It contains fact table and surrounded by like a different dimension table, and each dimension table again we have sub dimensions. See here down, this is the fact table, and we have like different dimensions. This customer is one dimension, product is one dimension, product class is one dimension, location is one dimension. See, staff is one dimension, time is dimension. Customer, product, staff, time. These are four dimensions I have. And customer dimensions we have multiple sub dimensions. Product also we have sub-dimension. Staff also we have sub-dimension. So here we have how many relations we have, see. Here we have many to many relationships. So that performance wise it can be reduced. And also dimension table is a normalized. Why? Dimension table is normalized. See, I have dimension table. I am going to split into different sub-dimensions so that it can be normalized. And fact table can be denormalized. Fact table cannot be like normalized. So always it can be denormalized. Any questions here? Skim apart. Navya?
In what case we use snowflake schema? Can you give some examples?
One second. Can you tell me?
Like in what situation we use star schema, and in like where we use the snowflake schema,
Very
then
good.
like how to select it, like
Yeah,
based
very
on
good.
what.
Yeah, very good. Yes. So the thing is, we have there clearly mentioned the documentation. These are the dimension table. These are the sub dimensions and all. These are the like fact tables we have. So my client is asking, I want to load all the like dimensions records into like facts. I have like 5 or 6 dimensions. So I want to load into this fact table. So in that case, directly we can use like star schema. I don't have any like sub dimensions and all. We can have only like dimensions. That's it. So whenever we have dimensions along with sub dimensions, we can go for like always snowflake schema. Is it fine?
Yeah, and does anything has any disadvantages? Both are good.
No, that's why like that's what I'm saying. Like when I have like only dimensions, so sometimes all the records it can be load, but performance wise it's a bit fast. Some cases I want only few records, the dimension table. I'm not updating keep on like all the records. Suppose I have like 100 records, 100 row columns. I'm not updating like all the 100 columns. I want to update only like 50 columns. Rest of 50 columns I didn't update anything. Whatever I have records, same records it's loading into fact table. So in that case I'm going to like my time is taking like more time. I don't want like unwanted like 50 records. I want to split into sub dimensions those records. What are the updated records we are getting, those data I want to load into fact table. In that case we'll go for like snowflakes. Fine.
And which approach we use, mostly top down or bottom up?
Always people will go for like top down only, lot of projects, but they'll go for the based on like requirements and all. They'll use like star, like star or like snowflakes. The 60% people will go for like star schema. The 40% will go for like snowflake. And what is meant by like fact table and what is meant by dimension table? So fact table means it contains only facts and measures. And also it can be having primary key foreign key relationship between fact and dimensions. And we have like different facts: additive, semi-additive and non-additive. Additive means I have the dimension table, I want to load all the records into fact table. It is called like additive. Semi-additive means I want to load only few records into fact table. It is called semi-additive. Non-additive means I don't want to add any record into fact table, but still my mapping is succeeded. So that will go for like later in the like mapping level. I can show you. So with my mapping is succeeded, but it's not loading single records also into the target table. So how? This is the scenario, the non-additive. So these are the different facts we have. And coming to dimension, what is meant by dimension? It won't contain facts, it will contain only measures. So and also we have many to many relationships. And we have here different dimension types. So one is slowly changing dimension and degenerated dimension, conformal dimension, degenerated dimension, conformal dimension, one more like role playing dimension, static dimension, and we have rapidly changing dimensions. These are different dimensions we have. See here, types of dimensions: slowly changing dimension, rapidly changing dimension, junk dimensions, conformal dimension, degenerated dimension, role playing dimension, inferior dimension, static dimensions. So we'll go for later this one, first one, slowly changing dimension. First we'll start with rapidly changing dimension. So what is meant by rapidly changing dimension? Any idea? What is general term called like rapidly changing?
Which changes fastly?
Yeah, anyone? Yeah, I'm asking it to you. Anyone?
Yeah, which changes fastly.
It's changing?
Very fast.
Very good. So which are the records? It's going to changing frequently. It is called rapidly changing dimension. Suppose I have 10 records in the table. 5 records is frequently changing. Those records called rapidly changing dimension. Fine. And one more, junk dimension. Junk dimension means so there is no use. So what are the like 5 records got updating? Rest of 5 records it's not updating. Like in almost all the scenarios. These are the junk data. I don't want to use those data. I want to split into some other table like subdimensions. This is called like junk. And conformed dimension means suppose date. Date is the conformed dimension or head date. Any one is like conformed dimension or like fact table also it's like conformed dimension. We can't change frequently. It can be conformed. Constantly it can be low. And one more, degenerated dimension. So degenerated dimension means suppose you are like doing any transaction from like your bank account to some other account. So it can be generated one transaction code for first time. If you are going to make one more transaction, it will be degenerating one more new transaction code. So this is called like degenerated dimension. And role playing dimension means same way we are going to use like multiple ways. Suppose we are purchasing any product or like anything. So like what is the date of purchase and date of like selling or date of so like what are the like exact how will call so date of purchase or date of sale and date of income like what are the like income exact you are coming. These are the same thing we are giving to like multiple ways. And one more, static dimension. Static dimension means it can be loaded constantly. So we can't do any updates will come. It can be loaded constantly in the database. So this is the called like different dimensions. And also coming to finally slowly changing dimension. This is very important. So almost Informatica projects we are using slowly changing dimensions. So what is meant by slowly changing dimension? We have different dimension like types. We have SCD type 1, SCD type 2, SCD type 3. What is meant by Slowly changing dimension type 1. Any idea? You are getting any bore? This is a theoretical part. It's almost completed. No worries. Fine. See, this is the type 1 here I have. So this is my source table. So here in the source table I have 10, 20, 30 department numbers and DNAME is research, HR, BPO and location is US, India, Pak. These are the source table. This is the target. So when I'm going to load into target, it can be load what are the current records I have in the source table. All the records is going to load into target. So if you can update any records here, HR to some IT and Pak to UK. Now by using type 1, it can be maintaining only current records. It won't go for like any historical records. So now if I am going to load into target table, it can be changed to HR to IT, Pak to UK. How about like previous record? Previous record, it's gone. I lost the data. Again, we are going to change same IT to some different sales and UK to Canada. Again, it will load. What are the current data I have? Same data it can be loaded into here. Canada. So like that it can be happen. So how many times we can update what are the current data we have? Same data it can be loaded into target. So this is called SAD type 1. Any questions guys on SAD type 1? Navya, Raga, Nipun? Fine, good. So next coming to type 3. So type 3, this is the type 3 we have. So here also I have 10, 20, 30, IT, non-IT sales, location, Dallas, Canada, India. So when I'm going to load first time, it will load all the records, DNA, department number, name, location, whatever data I have, all the data it can be load. But the structure is we have different. The previous DNA, previous location. So when I'm going to update any record here, non-IT, some BPO or India to Park. Now I'm loading into target table. So what is the output here? Anyone can tell me guess? Any guess? No. Fine. So the previous name is, what is the previous name? Non-IT. It can be loaded here. Non-IT and Canada. And coming to here, sales and here instead of India, it will load like India here. Here it can be updated BPO. This is the current data. This is the previous data. This both is previous. This is both is current. Again, I'm going to change BPO to research back to SCA. Now it can be changed BPO in this one park, but here research SCA. So like that it can be updated. These are the current records, these both are like previous. So like that we have to update 10 times. It will load what are the current records here, and ninth record it will load previous name, previous name. This is so we are using type 3. Any questions here? Using type 3. Okay, good. So coming to type 2, this is very important because of almost all the projects we are using type 2. Type 1, type 3 we are going to use like a less, but type 2 is almost like every day we are going to use full load and normal load. We have different loads we have. See, buzzing SCD type 2 we have different ways. One is flag, version, date and time. 3 ways to do. Buzzing flag. So we have to like hard coded the value flag equal to 1. 1 means the current record and 0 means historical record. So like that we have to give it flag equal to 1 means current, flag equal to 0 means historical record. So based on flag we are working on the same now. So this is my source table, department number, department name, location. So when I am going to load first time, it will load all the records into target table, but the flag is what is the flag for our current records? 1 1 1. So for history records it can go to 0. Now there is no historical records, only current records. Whatever data I have in the source table, same data I have loaded into target table. Now I got update anything here, HR2 India to. Now what will happen now? Anyone tell me here? What is the expected output here? I updated two records, BPO and POC. BPO instead of HR, POC is instead of India. So what is the output in type 2? Navya? Okay, Raga?
I think it will store the latest information with the date and time change.
Okay, good. So what is meant by like type 2?
It has a flag.
That's fine. So what is main use? It can be maintaining current and all the historical records, right? So if you are going to maintain historical records, so there is like some standard format, right? I want current and historical records both.
Yes.
So can you tell me now?
I think it will. It has both the call like 10 IT US and then again 10 the updated record. It has the previous record and the updated record.
So here 20th record updated and 30 record updated.
Okay, 20th record.
20th record can be loaded here.
Yes.
And PPO, then UK. What is the current flag? This is the 1. This become 0. This is history now. 30
Sales.
sales park. This is the flag one,
And the previous one becomes
and India is like become 0. Again I'm updating any record here. One record I'm going to update here. So BPO2 research. Now only one record got inserted. RES research UK. This is the one, and this become 0. So like that I'm going to like update 10 or 20 times. 20 times I'm updated. So now my requirement is I want to display how to find out flag like current record and 10th updated record. Because of current records we can easily find out based on like flag equal to 111. So how about like historical records? All the historical records it can going to show like 0000. How to find out it's like a 10th modified record or not? Any idea?
Can you repeat the
See, we can easily identify what is the current records. But my record I have updated 20 times. Now I want current and 10th updated records.
current? We can find out with the flag.
Yeah, flag equal to 111, we can find out. How about let's stop like 19, we have 0000, all the zeros. Oh,
Previous
previous?
row. If it is like stored sequentially, then we can just go to the
Not required. Just now you said like date and time. Based
okay.
on date and time only, we have to find out.
Okay.
Is it fine, guys?
Yes.
Based on date and time, we have to find out. Good. So these are the concepts we have in the data warehouse we have. So out of these questions, almost they'll go for like, so what are the approaches you are using, top down and bottom approach, and what are the like schemas we have, star schema, snowflake schema, when we're going to use, what are the like differences between those, and what is mean by fact table, what is mean by dimension table, what are the facts and what are the dimensions, and they'll go for like some dimensions, what is the use of the particular dimensions and all. At least they'll ask like 3-4 questions on like data warehouse concepts. These are like straight questions. There is no like confusing questions there. And which table is loading as a like a dimension table or like a fact table? Which table is loaded first means we can say dimension table. It can be loaded first, then only it can be loaded into fact table. Fine, guys. Any questions here? So these are all theoretical part. This is of only like entire point of view. This is all out of whatever we are discussing today. All the concepts for entire point of view. And now we'll go for like Informatica level. What are the like different client tools we have? Nipun, designer, manager, after manager, monitor, good. and repository manager. Very good. These are the 4 client tools we have. So what is meant by repository manager? We can store all the metadata in the repository manager. If you want to add any like repositories, project folders, we can add it. It can be reflected by default rest of all client tools. I don't want to create those repositories and project folders under mapping or workflow manager. So this is one. And we have any like deployment things, we have to do deployments and all here. And coming to Power Center Designer, so what is the main use of Power Center Designer, Nipun? How to create mappings. And so what is the source, what is the target? Between source and target we have to choose list of transformations, then we are implementing logics and all. So under Power Center Designer we have like 5 components. One is source analyzer, target designer, mapping designer, transformation developer, and maplet designer. So coming to here, mapping designer. See, we have before discussing about like this 5 client components, we have 3 parts here: a repository navigator, this is mapping designer, this is output window. So what is the use of repository navigator? So what is the repository I have? You can able to see it here. And under repository, what is the project folder name? Under project folders, we have what is the source, what is the target, what is the transformation, what are the maplets, what are the mappings and all we have. We can able to see it here under repository navigator. And coming to mapping designer. So how to create mappings? After creating mapping, we can save our mapping. We can able to see under output window, my mapping is valid or invalid. We can able to see under output window. And the real-time environment. So while creating mappings, we have some naming standards like mappings, workflows, maplets, sessions and all. So for mapping means m underscore whatever name we want to give, we can give it. Now coming to these 5 components. So we have source analyzer, target designer, transformation developer, maplet designer, mapping designer. So by using source analyzer, how to import table from database to Informatica. So by using source analyzer, we are going to import table from database to Informatica. This is the main use of source analyzer. So once we are importing table from database to Informatica, we can save it here. It can be placed under sources. If the same table it's required for the next mappings and all, again I don't want to go for like database import same table from database to Informatica. So we can drag and drop from under source to source analyzer. So these source tables and all inbuilt tables already they have created. So we don't have any access to write access. We have only read only access because of there is multiple projects. And the next one is target designer. So the target designer, so we have to create targets and all based on source table. We have to create target table and source tables and all we are importing from database to here. But target table we are creating like in Informatica side, we are generating into again database. So how to generate and all we'll go for later. And coming to transformation developer. So what is the use of transformation developer? So I have 15 transformations. We can choose any one transformation. Then we can implement 30-40 logics. It's taking 5 hours time. The same transformation I'm going to use some other transformations. Sorry, some other mappings. So again I want to spend 5 more hours. So I don't want to go for like this way. So whenever we're going to create any mappings and all, like transformations and all, so we have option make reusable option. See, this is the my transformation. We have make reusable option. If we can save, enable this one, it's asking converting to the current transformation into reusable transformation. It's not reversible. Once it can become a reusable transformation, it's not possible to convert as a non-reusable transformation. We can't do anything. Right? So like that we have to use make reusable. That too only one transformation as a reusable transformation. Coming to Maplet Designer. So by using Maplet Designer, we are using more than one transformation as a reusable transformations. So the interview point of view, they'll ask what is the reusable and mapping like Maplet. Reusable means we can go for like always one transformation as a reusable, but Maplet is using more than one transformation as a reusable. And finally, we are coming to Mapping Designer. So what is the source? What is the target? Between source and target, we are choosing multiple transformations. We are implementing the logics here. So this is how we are creating mapping. After creating mapping, we have to save it. Control yes. It can be saved under output window. See the navigator window. If you want to see, that's fine. If you don't want to see, if you want to hide, you can go to here. The mouse. See the mouse. Toggle navigator window. Click on this one. It will like gone. Again, if you want, you can click on this window. You can able to see. Even output window, if you want, you can keep it like this. If you don't want, you can see here Google output window. It will be gone. This is how we have to create mapping. So the second one is now that what is the next step? How to move data from source to target. So by using workflow manager. So how to create workflows. See, this is the integration service. How to move data from source to target by using integration services. So go to the workflow manager. So we have to create the workflow and then we have to create session, nothing but a task. Then we are giving the link task between source and workflow and session. Then we are using under session source and target database connections and target flow type. Then we are going to save our workflow. After saving my workflow, we can run the job. If the job is succeeded, it will reload whatever records they have based on requirement. We can check it in the workflow monitor for client tool. Still you are not getting anything. We have to go to get run properties means this is the one. How many source success rows, how many target success rows, how many failures we have. And then get session log, we have to go for still you are not clear. We'll go to the session log, we'll get like clear picture. So these are the things we have. This is the logically we can see the data under workflow monitor. If you want to see physical data, we can go to database side, that to target table. Is it fine? Any questions? Raga? Good.
Yes. And
Yeah, tell me. Any questions?
what we do in workflow monitor?
Monitor just we are monitoring the jobs, whether my job is succeeded or failed. If it is succeeded, we need to check the status, how many source success rows, how many target success rows, how many source failed rows, how many target failed rows. If you still you're not clear with that, we'll go to the session log, get session log. There we have a clear picture. What is the mapping? What is the repository? What is the workflow? What is the session? How many records I have? I'm going to loading into like target table. If the records is loading or not, we have to check it the status or not. That too large like it's not like physical data. Just logically we can see the data high level. If you want to see physical data, we can go to database. We can check it there. Fine. Nipun. Fine. Good. So then like from tomorrow onwards we'll start with like the sample mapping with. So again I'm going to give you like clear picture. So what are the different client tools we have, and each and every client tool what is the use. Then we'll start with like actual class from tomorrow onwards. Is it fine, guys? Good. Nipun.
Yes. So you said it takes 25 to 30 classes,
Correct.
and we're doing 1 hour every day for 5 days a week. So it will take approximately 6 weeks. Can we do 2 hours a day if it's fine with everyone, so that we can finish it in 3 weeks?
And Navya, you can tell like discuss with three guys. I don't know any problems to continue like 9 to 10 also. I'll like continue with the session.
No, I don't have any problem. Yeah, it's okay.
Okay, fine. So the initial like three classes go for 1 hour. So if you are familiar with these sessions, then I'll go for like a speaker. Can you meet anyone like Navya? Navya,
Yeah.
you can mute your volume.
Yeah, that's not a problem. Yeah, we'll go with the same thing. Like 2 hours a day, that's fine.
Okay. The initial three classes you have to understand the tool, how to work on. Nipun, is it fine? Okay. So from like Tuesday onwards, we'll go for like 2 hours. So IST Tuesday, 2 hours. As of now, we'll cover it like a basic transformation, source qualifier, filter, router, sorter for like everyday one transformation. So if you have any queries, you can ask me like before these 4 days. Then we'll start with the real work. And we'll start with some scenarios part, the real-time scenarios. And even like I'll give like some scenarios to you guys to assignments and all. You can practice it. Okay. So then tomorrow we'll start at the same time, 9 o'clock. Fine. Nip. Yeah, welcome. Fine. Thank you so much. Bye. Bye. Have a nice day.